So chapter 5, we're going to be looking at the normal distribution. The main focus of this chapter is the normal curve and using it to find probability. So we're going to look at 3 methods of finding probability. The first part of 5.1 is kind of just a little intro to distributions and density curves, what we're going to be looking at. And I do add some things on the consumer price index in 5.2, just to kind of add a little more to the chapter. It's a kind of a short chapter. Okay, so 5.1, the normal curve. Okay, distribution is how the data is spread out. We looked at histograms, dot plots, box and whisker plots, a bunch of different displays that are showing you how the data is spread out from one category or interval from one to the next. Okay, we're not focused on the normal distribution. Let's just get a quick review on a couple other things. A density curve. A density curve is going to be the outline of your histogram. So we're looking at our histogram, we're seeing how it's spread out. The density curve kind of is just a trace to give you a more smooth look of what's happening. Okay? So if we're looking at density curve here, I'm just on a trace. Start from one edge and just go from point to point. Okay, and we can see it goes, and now if I would take away the histogram, you'd see a density curve that was skewed to the right, has its peak, and then it flattens out on the right-hand side. Okay, I'm not really you don't need to go, unless there's like multiple intervals where there's going to be a valley, you don't really need to go in to every single one. Kind of how I touched every point here, every corner, that's not a necessity. Okay. If I was this, I would just trace these points. Like I said, not really going down to hit those. And since this one kind of dropped so fast, I didn't get there, I'm not overly concerned about it. But this would be the density curve for that shape. A little more symmetric in that case. And it does have some ones that aren't exactly standing out there, so they're not exactly a smooth curve we would have. Okay? Okay. Underneath the density curve is 100% of our distribution, and that's kind of what we're going to use for the finding probability. Okay. No matter if it's symmetric, skewed to the left, skewed to the right, each one of these, if I trace my density curve, represents 100%. Okay. So no matter which curve we're looking at, skewed to the left, underneath is 100%. Even if we have a uniform. Now, a uniform distribution is when every interval, this is kind of very extreme where every one is exactly the same, but if we have it where our distribution are very similar to each other in every single interval category, we say that's a uniform distribution. If I draw a density curve, okay, and underneath would represent 100%, okay? So breaking that 100% up is what we use to find our probability. Okay. Now let's explore the uniform distribution just a little more. Okay. Here's a uniform distribution. This would be our density curve, and this is just random digits selected. Okay, so we would have our intervals going up, and this would be what we would have. And you can see it goes across by 1, up by 1. And that's just showing you 1 times 1 is 1, which is 100%. We have a 100% filling in our density curve here. But that's basically what a uniform distribution is going to look like. Okay? About where does the median fall? Well, the median falls in the middle. So our median would be right about 0.5. Where does the mean fall? We're balanced on one side or the other. This is very similar to a symmetrical distribution. So if the median is 0.5, our mean is also going to fall about 0.5. Again, that one that I showed before where it was completely smooth across, that was kind of extreme. There's usually some kind of bumps here and there, not exactly the same, but extremely similar. About what percent of the digits fall between 0 and 0.4? Well, again, if it's 100%, this is what we're going to be doing. We're going to be looking at the area that's being filled in. So if we're looking from 0 to 0.4, let's just say 0.4 is right about there. Okay. How much would we cover in there? The area is what is our probability. The distribution is 100%. That's about 40% of our distribution. Okay, so that's basically what we're going to be doing. And the last thing, think of another situation that would give you a uniform distribution. Anything that would be called up and it would be equal in all your categories or intervals. Let's say if I surveyed my class and asked, okay, what day of the week were you born on? Okay, most likely each day of the week, Sunday, Monday, all the way to Saturday, is going to be fairly even. Randomly selected what day people are born on. So those 7 days probably have an even number of people. Okay, those are the types of things that would be a uniform distribution. Okay, things that are going to fall randomly and almost equally. Okay, proportionally. And looking more at the normal curve. Now this is what we're going to focus on for the rest of this section. Okay, our normal curve, also called symmetric and bell shape. The left and right hand side are equal to each other. They call it bell shape because the tails flare out a little bit like a bell has on the end. Okay, our center is always going to be our average. Okay, so whatever our average is for our distribution, that's where our center is going to be. Okay, now that center doesn't control too much about probability. What does control the probability is the standard deviation. Okay, now we talked about standard deviation and we calculated the formula for standard deviation. Okay, average distance of value is from the set's mean and it's measured. Okay, we know our mean is the center. How far away are all of our points in our data set from that mean? And we measure out that, and that's going to determine how wide our normal curve is going to be. Again, no matter what, it's 100%. Okay? The standard deviation will determine the shape of the curve. And what it means by that, we're going to have a shorter, wider curve. This is if you have a large standard deviation. Okay? Because larger standard deviation, things are farther away from the average, so things are more spread out. If we drew a histogram in here, the bars are not going up quite as high towards the average because they're spread out. We're going to have some shorter bars because things are inconsistent. For a smaller standard deviation, okay, things are closer to the average. When things are getting close to the average, these bars, probably draw them in here, are going to be a little higher. If you can imagine the histogram here, okay, bars are going to be a lot of values, scores are falling in the categories around the average. And if they fall in those categories, the more that fall in there, the higher the bars are. Less fall in around the average, the bars are not quite as high, and they're more spread out. You might have more bars going to the left and right, just not as big, not as tall, because not as many scores fall into those averages. So what we're going to look at here is how spread out these values are. Okay? So again, a large standard deviation, usually a shorter, wider normal curve. A small standard deviation is going to be a taller, skinnier curve. Things are very close to the average there. No matter what though, remember, no matter the shape of the normal curve, we have 100% and 100%. Okay? The distribution, entire distribution, 100% fits into our normal curve. And the center is not going to move. If our mean is in the center, that's lined up, that's what we're looking at, and that's not to stay right where it is. The area around that is what we're going to use for the probability. Okay? So the next part of chapter 5, we're going to be looking at 3 methods. Okay? 3 methods of finding probability. So you can go on to the next video to do some practice with that.